By default, modules are eagerly loaded, which means that as soon as the application loads, so do all the application's modules, whether or not they are immediately necessary. While this is fine for most applications, it may become a bottleneck for applications or workers running in a serverless environment where having little to no startup latency or cold start is absolutely crucial. Lazy loading can help decrease bootstrap time by loading only the modules required by a specific serverless function invocation. In addition, you could also load other modules asynchronously once the serverless function is warm to speed up the bootstrap time for any subsequent calls even further. This is known as deferred modules registration. Most commonly, you will see lazy loaded modules in situations where your worker, cron job, Lambda, or serverless function or webhooks must trigger different services or different logic based on any given input arguments, be it route path, date, query parameters, etc. On the other hand, lazy loading modules may not make too much sense for monolithic applications where the startup time is rather irrelevant. So let's get started by switching to our IDE and see how we can lazy load modules in Nest.js. First, let's start off by generating a new rewards module. Note we're using the skip import flag here to instruct the CLI to not add the newly generated rewards module to our root app modules imports array as we want to lazy load it. Next up, let's generate a single reward service within this module. With this in place, let's navigate to our coffee service file, and before we start, let's inject the new lazy module loader provider using the standard approach. With this dependency in place, let's now move on to the create method, and first, let's update the method signature to be async. Next, let's use the load method of the lazy module loader provider to lazily load the rewards module. The lazy module loader load method returns the module reference of rewards module here, which lets us navigate the internal list of providers and obtain a reference to any provider using its injection token as a lookup key. Next up, let's retrieve the rewards service class reference as follows. And lastly, let's use that reference to retrieve the corresponding provider. Just so we can test everything out, let's open up the rewards service and add a random method in there that console logs some text. Great, let's save our changes, head back to the coffee service and call that method from within there. Great, now onto our terminals. Let's make sure we have the application up and running in the background with npm run start:dev command. And let's open up a separate terminal window and use curl to call our post/coffees endpoint just to test everything out. Great, as we can see, no errors. So let's switch back to the other terminal window with our app running. And as we can see here, there's our hello from the lazy loaded rewards service message, which was logged to our console just as we should have expected. Now what happens if we call this endpoint a second time? Will the rewards module be loaded once again? Well, lazy loaded modules are cached upon the first lazy module loader load method invocation. This means that each consecutive attempt to load it will be very fast and will return a cached instance instead of loading the module all over again. Just to prove that it works, let's head over to our create method and use the console.time and console.timeend methods there so we can measure how long it takes to retrieve the rewards service instance. Let's save our changes, head back to our terminals, switch to that second terminal window, and run that curl multiple times. Next, let's switch back to our applications terminal and see what got logged to our console. And as we can see, each consecutive attempt to load rewards module was much faster as the load method simply returned a cached instance instead of loading the module again and again. Of course, our example here isn't one you would likely do in the real world. We kept things simple in this lesson and just used our existing application, just for demonstration purposes, of course. But achieving everything we did here for whatever scenario you need in the future, whether it's for microservices, cron jobs, serverless functions, etc., just know that everything could be achieved exactly the same way.